A rational expression is an algebraic fraction. It's a fraction, just like any of the other fractions you've been dealing with in all of your life. Only now we're throwing some x's in. So, for example, x minus 3 over 4x plus 7 over 10x squared. These are both individually rational expressions. They both have x's in them. They're both fractions. And they behave in a similar way as fractions. They just do things, we just treat them a little bit differently because they have letters in them. But as far as adding or subtracting, or for that matter multiplying or dividing them go, the process, the overall process, is exactly the same for these as it is for the regular fractions. So I need to find a lowest common denominator. The lowest common denominator, when we have monomials in the denominator, that's what this video is about. When we have monomials in the denominator like these, finding the lowest common denominator is kind of, there's two parts to it. We want to look at the coefficients and think, what's the lowest common denominator between 4 and 10? Well, that'd be 20. And then we have x and x squared. And I could just multiply them together and get x cubed. But remember, we want the lowest common denominator. If I just multiplied this over here by x, the 4x over here by x, I would get an x squared, which would match the x squared over there. And so x squared would be part of my LCD. X squared is the lowest common denominator. The lowest common denominator, it's the least amount of stuff that we have to put into our denominators in order to get a common denominator. So in this case, the common denominator is 20x squared. I always recommend writing it out like this first. Rewrite your expressions with the same denominator. You might probably do this when you're doing just regular numerical fractions as well. You should. If you don't, you should. It's a good strategy, because it helps you know exactly what it is that we need to get. We need to get 20x squared, so I have to multiply this by 5x, which means I multiply the top by 5x. And I get 5x squared minus 15x. On the right, all I need to do is multiply that by 2, so I multiply the top by 2, I get 14. Now I can add these two expressions, put them all over one denominator. 5x squared minus 15x plus 14. And that's actually it. There's no like terms up here. I can't combine anything. So this is it. This is my finished product. I should check to see if 5x squared minus 15x plus 14 can factor, if I can use splitting the middle for this, and see if it can cancel with anything down here. But I'll save you some time right now and tell you that it doesn't. This doesn't factor. Now, what if we didn't want to, or we couldn't find the lowest common denominator? Because you don't always have to find the lowest common denominator. If you can get any common denominator, if you can get your individual expressions to have any common denominator, then you can combine them. The lowest common denominator is the goal. Really, that's the one you should be looking for. But any common denominator will do. And so, if you're having trouble figuring out what the lowest common denominator is, just multiply the denominators together. 40x cubed. And use that as your common denominator. It's not the lowest common denominator, it's a common denominator though. So let's see what happens when we do that. So I multiply this over here by 10x squared. So I get 10x to the third minus 30x squared. And on the right, I just multiply this by, 4x. So I multiply the top by 4x to get 28x. And so again, I combine them into one expression, 40x squared. I get 10x cubed minus 30x squared plus 28x on top. The thing is, this is not done. This is not in simplest form. We always want to make sure that our expressions are in simplest form. The top here I can factor. I can't use splitting the middle, but I can take out a GCF. I can take out a 2 of all of those coefficients, and I can also remove an x. So 2x will be my lowest common denominator, or my greatest common factor, rather. Greatest common factor. And so taking that out of each of these individual terms, 10x cubed divided by 2x is 5x squared. 30x squared divided by 2x is 15x. And then 28x divided by 2x is plus 14. And that's still all over 40x cubed. That should be cubed. And now we can reduce. The issue with not using the lowest common denominator is that you'll always need to reduce at the end. If you do find the lowest common denominator, you won't have to reduce. When you have monomials in the denominator, I shouldn't say never, but most of the time you won't have to reduce. But if you don't find the lowest common denominator, pretty much you'll always have to reduce the fraction. So 2x, 40x cubed, I can cancel the 2 with 40 and get a 20. I can cancel the x with that and get a 2. And so I'm going to write it up here. My final answer is 5x squared minus 15x plus 14 all over 20x squared, which is what we would have gotten had we just used the 20x squared. So always try to get a lowest common denominator if you can. If you can't find the lowest common denominator, just go with any common denominator. Multiply all of the denominators that you have together, and you can get something. If you can get something to have in common for your expressions, some common denominator, at least you'll be able to combine them, and then you can reduce it afterwards.